Guys, this unit is on functions. It's an introduction to functions. And typically when we start out with functions, we start out with talking about relations and functions. But for this one, I started out with interval notation, and it's a kind of an overview of what you can expect as you move forward in algebra. Um, and the way that we notate intervals. The first part of this is just a warm up. Uh, you should attempt the problems and check your answers, and you should get one solution for each one. But we're going to go right into the notes for interval notations. So basically today we're going to define an interval using set notation. So first of all, an interval describes the beginning and end of points on a line. We use in algebra 1, we use set notation to describe this interval. It's a shorthand of the interval and all the points in between, right? The endpoints. So first, I just wanted to kind of show you what an interval with endpoints 3 and 8 would look like. 3 and 8. This one's filled in down here because of the bracket, and this one's not. And then we just connect the two endpoints. So here, my interval is, the endpoints are 3 and 8. On the other hand, when you're dealing with this infinity, if you deal with negative infinity, positive infinity, we only have one real endpoint, one endpoint that we can actually define. So there's no end towards the left. So it's going to start at 2 and go forever towards the left. Okay? Now, so we have this symbol in math. It's a R with a double bar. And it implies that we're talking about all real numbers. So when we say that, we're saying that x equals all real numbers. What we talked about during the last unit is we said that x equals infinite numbers. But it's essentially the same thing. So we're going to put a little AKA here. These mean the same exact things. So if I was going to make you write all real numbers, I'm going to start at some weird number. We'll say negative 1,000. Well, the next number going forward is negative 999. And we're going to put a little dot, dot, dot in front to kind of denote that this can get more and more negative. Negative 998, negative 997. And instead of writing all these numbers in this fashion, we use, like I said, the R with the double bar, or we use the words themselves, all real numbers. Okay? Now, when we're talking about going towards a positive direction, going towards the right or the left, we're talking about infinities. So negative infinity implies, or negative sideways 8, means the line extends forever towards the left. So I might have an interval that looks like this, and all of the values in between are my x values, but it's extending forever towards negative infinity. Now positive infinity, you'll have an endpoint. Positive infinity, you'll have an endpoint, and it means the line extends forever towards the right. So you'll have an endpoint, and we're going forever towards positive infinity. Now, what about when we're describing that? What about how do we write the set notation for it? So next we're going towards negative infinity, and we have all these values in between, and then we have an endpoint of 2. So we're going to find 2, make the endpoint, and we're going to create our interval. This is our interval going towards negative infinity. Here's all the x's in between, and here's 2. The only thing that's important about this interval really is when we're using set notation is that x is less than 2. And we say curly bracket x bar because we're talking about x values. X is less than 2. On the other hand, when we have two endpoints, let's see, we start at 3, it's filled in, and we go to 8s, right? So what's important here? We're going to write curly bracket x bar 3 less than or equal to x less than, oh, this is infinity. That isn't an 8. That's infinity. Let's be careful here. So let's look at this again. The only thing that's important is this part. So we start at 3. It's filled in, and we go over towards positive infinity forever and ever. So the only thing that's important is curly bracket x bar 3 is less than or equal to x, close the curly bracket. Now, set notation describes all of the points included in a set or an interval. The set is enclosed in curly brackets and a variable. So we could have x bar or we could have curly bracket y bar, but we're not there yet to describe a set. For now, we're going to be looking at x bar. So basically, we're going to just go ahead and graph these intervals. We have endpoints of 3 and 6. So here's 3, here's 6. It's filled in at 3. So here's my x values. Have endpoints of 3 and 6, less than or equal to, less than. And when we write the set notation, we have curly bracket x bar 3 is less than or equal to x is less than 6, right? Over here, we start at 2, and we go over towards negative infinity. So remember I said the infinity portion wasn't important. It was just the x values and the endpoints. So x is less than 2. So here we have curly bracket x bar. X is less than 2. Don't worry. You might be confused, but you have to stick with me because in the example, you'll see where I'm going with this. You have to stick with me. So the U in a union, it's also called a union. The U in between two intervals, it's called a union. It joins two intervals when there is a break between and there is a need to describe a set of numbers in shorthand. So if I was going to describe the union of 3/8 and negative infinity 2, I would write the smaller interval first, or the number with the numbers that are smaller first. Union, hard bracket 3, comma 8, close parentheses. And that's all you do for a union. And this is more for your information as you move forward in maths. But right now it's not particularly important, but I just wanted to introduce the concept to you. So the union on a number line, that same union, we would be at 2, and we'd be going over to negative infinity, and then we'd go from 3 to 8, and we fill in at 3, I believe. Now, on your homework, they're going to ask you to describe graphs in one dimension, an interval, and set notation, but we only want to do set notation, and we want to identify the endpoints. This makes it easier to set up the set notation. So first, I like to go to my graph and identify the endpoint. So I have an endpoint of 5, and I have an endpoint of 7. All of the values in between are called x values. Now, it's filled in, so 5 is less than or equal to x, and x is less than or equal to 7. So when I'm writing this, my endpoints are 5 and 7. My set notation, curly bracket, x bar, 5, less than or equal to x, less than or equal to 7. Now look at the next one. We have endpoints of 5 and 7. All the values in between are called x's, less than or equal to, less than or equal to, nope. So it can be equal to on this side because the hole's not filled in on 7. But my endpoints are 5 and 7. So I have curly bracket, x bar, 5 less than or equal to x less than 7. Next one, I have I have same endpoints, the same endpoints, right? So I have 5 and 7. X's are in between. Less than X less than 7. So endpoints are still 5 and 7. Curly bracket X bar. The only difference is that I don't have any equal to's. 5 and 7 are not included in the sets. Now, looking at the last two, I'm going off towards the left. So I'm going towards negative infinity over here. And I move all the X values in between are between negative infinity and 6. So at 6 it's equal to. The only thing I care about here is this portion. I never really care about infinities. So 6 is my only endpoint. I have curly bracket, X bar, X is less than or equal to 6, close the curly bracket. Other parts, I have 2, X less than 2 is less than, which is less than positive infinity. The only thing I care about, not the infinities, is the number and the X solutions. So 2 is my only endpoint, curly bracket, X bar, 2 is less than X. And it's not equal to. Okay? At the bottom, there's nothing. All right? So, moving on to set notation in 2 dimensions. So previously, we wrote interval notation and set notation in only 1 dimension. Graphs typically have 2 dimensions. We can go not only from the left to the right, we can also move up and down. The domain consists of all X values. We're talking about X values when we talk about domain. The domain are the X values. They extend from the left to the right. Okay? So in general, if I have a continuous graph, this map, which maps off of a graph, and I have a line that's pointed towards the left, and it heads off the map towards the left, even left and up, directly left, left and down, we're going to a place called negative infinity. Now, before we get started with that type of thing, I wanna actually just do the very first one. So we're gonna write the domain of the objects below in a set, and set notation only, not interval notation. We want to do one type of notation at a time here. So first of all, there's a little block that says continuous or not continuous. So the thing about continuity is whether or not points are connected, whether or not points form curves, whether or not points form lines or V's or whatever it is. So these points are not connected, and they're not continuous. They are not continuous. That sets us up to look a certain type of way. Our interval is going to look a certain type of way. It's not going to be this less than or greater than. It's going to be distinct points, and it's going to be exact and equal to. So here I have an X value at -2. I have an X value at -1. I have an X value at 0, 1, and 2. So here, my domain, my X values, X bar, X equals -2, -1, 0, 1, and 2. And we close the curly bracket. Now, on the other hand, I just told you, if we're heading off to the left off the map, we're going towards negative infinity. Our numbers get more and more negative. If we're headed off to the right, we're going towards positive infinity. And the thing about having a map where all my X values in between are between infinities, for set notation, definitely it's continuous because it's going from one extreme to the other. And what it becomes is x equals all real numbers. Okay? Same thing with this map over here. It's headed over here. It keeps getting more and more negative as you move up. So it's going negative infinity over here, positive infinity over here. And it's continuous because it's a map going off the graph. And x equals all real numbers. Now, the range, on the other hand, consists of all the y values that a point touch. The range are the y values. There we go. Extend going up and down. Up and down. So what does that mean? Well, our first range value is y equals 0. Second one is y equals 1. Third is y equals 4. So when we write the ranges, knowing that the first graph is not continuous, it is not continuous, right? We had those distinct points, so we're going to have distinct answers. So let's take curly bracket, y bar, y equals 0, 1, and 4. Close the curly bracket. Now, if it's going downwards, the range, we're talking about y values. If the range is going downwards in any direction, we're going towards negative infinity. If it's going towards positive infinity, it means it's pointing upwards in some direction. So here we have continuous, and we're going towards negative infinity here and positive infinity up here. And the y's are in between, right? And we have y, curly bracket, y bar, y equals all real numbers. Okay? Now we got to be careful here for the next one. The next one, look at your y values. Where do they start? The lowest y value is at y equals 0 here. But for the curve, if I keep going up, these y values keep getting bigger and bigger on both sides of this curve. And they're going towards a place called infinity. And here's all my values in between. Here's all my y solutions. And our set is essentially, it's continuous. But our set is essentially y bar. 0 is less than y, less than or equal to y, because it's on the curve. And we're done. Okay? So next part, we're going to write the domain and range using interval notation. So your domain here, here's my x values. It starts at 5, and it's less than. And then all these x values in between. All of these x values in between. The x values go over to where? On the x-axis. They go over to 3. So we essentially have 5 is less than x, which is less than negative 5 is less than x, which is less than 3. So for my domain, x values only, negative 5 less than x, less than or equal to 3. Now the range, I expect you to turn your paper sideways. We had a big discussion about doing that earlier today. We turn our paper sideways. We can see that range a little bit more clearer. Now a range starts at that most negative number, the most bottom number, negative 4, and it's less than all these y values in between. I go all the way up, and it's equal to 5. Okay, so my range becomes curly bracket, y bar, negative 4, less than or equal to y, less than or equal to 5. Now, I go to the right to 2, and my y value is 6. So here, x equals 2, and I go up to the curve, and I catch 6. For your domain, on the next one, starting at negative 3, here's all the x values in between. And we're going towards the right, towards positive infinity for domain. So here, only thing that matters is this. So curly bracket, x bar, -3 less than x, close curly bracket. For my range, starting from -infinity going up to my y values, and y is less than 4. There's my range, curly bracket, y bar, y is less than 4. Close the curly bracket. And here y equals 2. And I'm going to go to where y equals 2. And I have two values. I have -2 and I have 1. So x equals -2, comma 1. For your domain, we start over here at -5. Yes, there's a break, but it continues on to 5. So domain is all the x values in between, less than or equal to, less than. So curly bracket, x bar, -5, less than or equal to x, less than 5. Close curly bracket. Your range starts at -3, goes up to y, less than, up to 5. So here, curly bracket, y bar, -3, less than y, less than 5. Close curly bracket. And here, y equals 4, for y equals 4, it looks like we're going to have, go to where y equals 4 right here. We have 3 locations. We have -1, we have 1.2 something, and then we have, looks like 3.5. So -1, 1.2, 3.5 are my x values when that equals y equals 4. So you have homework tonight. Please do it. Have a blast. Make me proud. See you guys.